Thank you. Maybe a bit of a clickbaity title, but hopefully live up to it. My name's Dalton. I'm a senior software engineer at Pytilia, and today I'm going to talk a bit about how an investment in developer experience became a very important tool in our tool belt. Over the past 2 years, as many of you have also seen, there's been a trend in clients asking for AI projects. And over these 2 years, we've worked on many different models, from classification models like OCC to forecasting models like LSTMs, to clustering models for anomaly detection, to NLPs for chatbots. We have covered a wide range, and from that I've noticed several trends when developing. Introducing Groundhog Day. So some of you may be aware of the Greek myth of Sisyphus, and when I was writing out these slides, I was thinking about that and how he was punished to a life of pushing a boulder up a hill, and every time it reached the top of the hill it would roll back down. And it may seem like a bit of an exaggeration to say that development software is the same as a lifetime of hell, but I thought it was an apt descriptor of how I felt when developing, doing the same things over and over again, especially in short-term projects that we had where there would be like 2 months or like 6 weeks, you would be repeating the same steps over and over again. So from both anecdotal evidence and from those that I work with, what started out as exciting AI projects, working with like cutting edge technologies, turned into repetitive grinds with an overall lower motivation. Delivery times seem to be harder to pin down, and not being able to determine how long it would take to confidently select a model, train it, optimize it, and deploy it for production use. Sometimes you would get 3/4 of the way through training one specific kind of model, and then you would find a pitfall at the end and have to restart the process again. So because of this, I reached out to some of the management in Pytilia and to tackle this problem, and because it seemed like it would be a bit of fun to work on, we decided to build out a framework to help make machine learning development easier. So the core principle of the design of this framework was to have a configuration-driven application where data sources, feature selection, which model to use, and its parameters could be defined within it, with a step then to train the model based on these parameters, test it, deploy it out to production, and then to monitor it as well. So having the ability to continuously train models and deploy them if they're better than the previous existing one. So we wanted to give developers an easy way to try out different models, comparing results and having the ability to optimize them. So here's an overview of the framework architecture, with the top line being an existing or a new ETL pipeline. Our framework firstly takes the data from the insight service, so there'll be data coming in from different data sources. It could be stored in a data warehouse or a database, passed through an insight service, like whatever your current AI model is. We ingest that into the framework. We then pre-process the data based on what we've defined in the configuration file. So that will be, imputing missing values, or selecting features, or customizing features, like creating new ones. Then there's the model retraining. So after that, the model's trained on the feature selection that we've done. Then there's a model evaluation step. So when the model is retrained, we evaluate based on the types we set in the configuration file. So this may be like, your mean square error, mean square error, ROC curves, or other statistical methods for evaluating the models. So when So after that, we compare the results of the trained model versus the previous existing one that's in production. If the new one performs better than the previous one based on the evaluation metrics, then we now have the ability to auto-deploy that out into production. So here's a small example of a basic configuration file. It's a simplified version of the YAML where we define the model type, the parameters, some basic pre-processed values, and some hyperparameter tuning values. So within the framework, we built in some additional features for engineer testing. So that's like data visualization, model analysis, and then the hyperparameter tuning that I just mentioned there. So the impact, so the overall impact of this framework is the ability for quick iteration. Previously, for each model we wanted to test, we would have to build a full pipeline. Where now we just have to change a few values in a configuration file, hit run again, we can compare different models against each other. Not just testing different models, but having a quick centralized way to like add, remove, or customize features makes optimizing a model far faster. Having the ability to compare models is vital as well, especially in our field of consultancy. Sometimes we have clients come to us looking for a forecasting model, but they don't know what specific model they want to use. So having the ability to compare different ones against each other is really important. The other thing I don't want to skip over is the ability to downgrade. Because you want the ability to roll back safely to a previous model version if the results start going bad. So having monitoring on the results of the data set or the analytics service is really important. So then the investment in developer experience. So this all came from us trying to invest in the developers in Pytilia and help out the developer experience. Specifically in our case, it didn't just help out the developers, it allowed for more innovative solutions and new ideas to make their way up. Anecdotally, I find now when we are testing out new models, I spend more time on the interesting parts and less time in the weeds, and this increase came about due to our investment in DX. So what can you do starting today? Starting small and auditing repetitive tasks is a good jumping off point. It allows you to have a bit more visibility of what's going on, and if there's any low-hanging fruit where tooling could help. There are already a lot of pre-built, out-of-the-box solutions for DX problems, and there's probably been a lot of them covered today that I'm sure a lot of you have some homework to go and look and investigate them, but also talking to your engineers and figuring out, is there some in-house solutions that solve industry problems, not just problems within your organization. At the end of the day, the most important thing is just to speak to your developers, see how they're doing, and see where their pitfalls are. So, thanks for listening.